Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about the multivalued dependency. What is a multivalued dependency? How to decompose using the multivalued dependency. And we will see that the introduction to the fourth normal form, that is the higher of the BCNF form. As we talk about the multivalue dependency, we can say that the multivalue part of an attribute, say whether an attribute has got the domain range of multiple values. Say that the person has got many addresses like the winter address, the summer address. So in this way, we can divide the structure or the decomposition so that it can preserve all the multi-values, also the dependency and the lower level forms on the BCNF, 3NF, 2NF and 1F. Now, if that is in BCNF, it sometimes lies that there are some preservation that is missing from the decomposition. Let us first look at this relation. Now, this relation is consisting of functional dependency. Now, if these two functional dependencies present in there, we can say that ID is not a key. This one is not trivial. So, this is not in BCNF. Now, it is in 3NF clearly. So, first we need to make it in BCNF and then talk about the multivalued dependency. As an instructor can have only one name present in the university, so the ID belongs to name. Dependency is preserving and also satisfying all the decomposition algorithm of the BCNF. Now the ID defines street and city is not being present there because we know that an instructor can have more than one address. So we no longer wish to preserve this preserving dependency. Now following the decomposition in BCNF, we can divide the relation in two of the relations. Now these two relations are in BCNF because ID and name lies with this ID belongs to name and ID department street city. That means there is holding the ID defining department. Now it does not hold for the ID defined street city again. So it is in BCNF but it is not in the multi-value dependency preserving. That means the street city can have a repeatance on a single ID corresponding to it. So how to deal with this? We have to introduce another part of dependency that is known as multi-value dependency. When a particular key depends on a multi-valued part or a multi-valued part depends on the particular key, then we can say that there exists a multi-valued dependency. Having this one as a consideration to our decomposition, I am decomposing in R2 in R21 and R22. Why? Because I want to preserve the department and ID preservancy, that is ID defines department, but not the ID defines name, street and city. So I have decomposed it into another one. Now, how to keep this third one as a part of this BCNF? Now, when I have made this street city as a multi-value dependency, then we can again use it as a decomposition in this multi-value dependency. Now, let us look at more clearly of how to deal with this multi-value dependency. Now we talk about multi-value dependency, then we are not taking a particular attribute, rather than we are taking an tuple or a record. When this multi-value suggests, that means for one ID there could be the street city and for this ID there could be another street and city combination. Now that means we are referring to a tuple here, not a particular attribute value. So that arises another normal form, that is 4NF, or the fourth normal form. So fourth normal form is higher than BCNF in this way, that it consists of the multivalued dependency. So if and only if there is a relation which is in BCNF and also has got a multivalued dependency, then we can say that the normal form is in 4NF. Now we often mention the functional dependency as the equality generating dependency because it actually generates the dependency on equal, that means ID on department. Now we call the multivalued dependency as a tuple generating dependency because it deals with tuples, not just the values of single attributes on a tuple. So here we need to consider it very carefully that how to deal with the tuple generating dependency, because every part of the tuple should match with each other so that they can provide a uniqueness to the relation. Now if R be a relation with the attribute set R here, then we can say if alpha and beta are the parts of R, that means they belong to the attribute set R, then there exists a multivalued dependency that is signed by an arrow with a double head to beta. Now it holds on a relation R if there exists any tuple that for T1 alpha equals to T2 alpha. Now we need to satisfy the following tuples. So for T1 and T2 that matches with the same value of alpha, we have got another tuples T3 and T4 in this way so that all their alpha will match. That means the ID of the instructor will be same, and now the beta of T3 will be equals to the beta of T1. That means any two parts of this tuples will be same for the dependent one. Now for another tuple T2, the beta, that means that is not present in R, or the set of attributes beta will be same with the set of attributes in T2. Because we are saying that T1 has got the matching value of beta with T3, so T2 cannot have a matching value of beta with T3. So there should be another one, that is R minus beta for T2, that we can match with the tuple. That means we are actually generating different values for matching with this T3. And if there is the R minus beta for T4 that is matched with T1, then it should match with T2 of beta. So if T1 and T2 holds the relation multivalued dependency, then we can say that the tuple T3 and T4 can match. If the T3 is matching with T1 beta, then it should match with T2 R minus beta. Same goes for the T4. Now we can calculate a legal instance R. What do you mean by a legal instance? That has not got any discrepancy in their information storing on the particular relation. So it is considered to be illegal if that is consisting or the lossless information, or there is a lossy information on that particular database. Now if we want to reform it in a tabular form, it should look like Now, if we look at the tabular form, then we can see that we have got the tuples in the y-axis as well as the attributes in the x-axis. So the tuples T1 and T2 are the formula for consideration, and T3 and T4 are generating. Now we have got alpha, that is the defining variable, beta, that is the dependent variable, and R minus alpha minus beta, that means the R which consists of all the attributes other than alpha and beta. Now what should look like this T1? Now for alpha, we know that every value of T1 to T4 should be same. Starting from A1, it should move to the AI, that the ith value of that particular attribute A. Now the beta will start from the AI plus 1 and it will move till AJ. Now for the T2, we know that these two cannot same. So there should be another value, let us say that B, which is starting from this one, not the AI that we have finished here, we are taking the B. So this AI is not the starting part of this beta because the beta is not matched with AI. That means the tuple has got multiple values. But see, we are not using bi to bj, we are using bi plus 1 because till the ith value we have considered the ai of that particular alpha and beta does not exist before the bi plus 1. The same goes with T3 and T4 because it also, if there is an A with the T3, then there should be another value for T4. Now let us move to the R minus alpha minus beta. Now my R consisting of the attributes not belonging to alpha or beta. So again it will start from AJ plus 1 and move till all the values present in the relational attribute. And for this B, it will be bj plus 1 to bn. Because other than the defining key, there should be no matching key for every tuple relation. So in this way, we can inform and express the multivalued dependency using this tabular form. Now when we are saying that this one, that means we are actually matching the T3 with different values with T4. Now let us see an example that how to define this one. But before that, we should know some definition on the formal part of the final value dependencies. Now, as we know to be in BCNF, we have to make every functional dependency trivial. So being a multi-valued dependency a trivial one, we need that the dependent key or the part of the dependent key will be always a part of the defining key. And also if we intersect of this alpha and b, that means if we join the alpha and b combination, it will form the R. That means R has got only the values of defining and dependent, no other keys present in it. That means it goes for the trivial checking. So for the multi-valued one, it also suggests in this way. Now let's look at the relation and then define multi-valued dependency decomposition from it. Now consider the R2 relational schema again, which is consisting of the ID, department, street and city. Now we have some redundant information acid. As we can see that the 222 and physics is repeated in these two tuples. Now we have got the street and city with two different names and the one-to-one finance as this one. Now, if there is a multi-valued dependency, that is ID, multi-valued street and city, that is present in this one, so we can say that the ID has got two different street and city, but as the department is being a part of it, we cannot say that this dependency is preserving. That means we have the same ID with two departments and that department has got same name. So the constraint, that is T1 alpha equals to T2 alpha, is solved here, but T1 beta is not equals to T2 beta, does not hold for this one. Now, if I want to remove the redundancy from this relation, so we can result in this relation. Now, if we look at this, that we can result in this relation if I want to fetch all the departments in the universities with all the city address that has the department or the instructor from the department has got. Now, if we end up in this one, it becomes an illegal relation because it does not contain that the ID 222, which has got some name and teaches in the physics department, has also an address in the Paris city on the lane main. Now we have only that the north and the right city of that particular instructor, but not the second one. So it becomes an illegal relation in this way if I want to remove the redundancy from it. Also, it does not follow the satisfaction rule for the decompositions in multivalued and BCNF. So we cannot reach just to reduce the redundancy in an illegal relation. So an illegal relation is a relation that has lost some physical information from it, not the logical one. Now we can check for the dependency preservation in multivalued one in two ways. The first way is to check that all the functional dependency, that being a trivial one, the super key constraint on, and also there lies a multivalued one. And the second way to test that every attribute set that is a part of in 4NF or multivalued dependency normalized form, that has got the attributes for the multivalued dependency as well as the functional dependency. Now, what is the difference between the functional dependency and the multivalued dependency? If it was the functional dependency, then we can say that the redundant application of the redundancy or the reduction to it is absolutely legal. But as we are checking about an multivalued dependency, is become illegal because we cannot have two values that is attached with one value and have the repetition of information in the relation. So the decomposition that the multivalued part that the tuple got one value match, then the second value should not match, is not satisfied here. So we should first calculate a functional and multivalued dependency set, say here D. Next we will perform the closure of that particular D to make it D plus. Now we need to check what are the functional dependencies that is present in D plus, also present in D, and the multivalued dependency, if it is in present D plus but not in D, or if it is in D but not in D plus. Now these two cases we will discuss explicitly. If it is in this D, then we can say that the multivalued dependency is already being a part of the denotation set and also in the closure set. That means the dependency is preserving. But if it is present in D plus but not in D, that means it is just being implied from any of the functional dependencies, and now we can have it as a closure. See, from no functional dependency, it can happen that we are logically implying another multivalued dependency. So this is not possible in this case of the 4NF. And we can clearly say that the relation is not in 4NF by checking this attribute constraint to it. So we can clearly say that if there exists a functional dependency, we can define a multivalued relationship from these two of the part keys from the functional dependency. So if there are a functional dependency on two attributes alpha and beta, then there should be obviously a multivalued dependency between them. And also if there is a functional dependency between alpha and beta, then the rest of the attributes that form within the relationship set R without the alpha and beta combination will be also as a multivalued dependency with alpha. Now that we have discussed multivalued dependency in formal definitions, the relation with the functional dependency, we can move to our next part, that is the 4NF or fourth normal form. So to begin our discussion on the fourth normal form, we first inform you that the fourth normal form is being the higher form of the BCNF. Now when we talk about the BCNF, the trivial and the super key constraint is already present in there. Now, if we go far beyond the BCNF, that means the multi-valued dependency. So that we need to concern about the 4NF. So we can design their lying of multi-valued dependency implied from a functional dependency. Still, the design is not a good idea for having a 4NF. Now let us look at the relation of the instructor department again. Now there holds a multi-valued dependency ID multi-valued depending on street and city. Now if it is lying, then we can say that it is absolutely fine to have in BCNF. But we cannot say that is a good design because the ID defines department is holding here. So that we can say that ID defines department. And from this definition, if there lies in ID department's definition, then also it defines that ID multi-valued department, which is not true for our case because we can say there is one instructor within each department and the instructor can have multiple addresses. So the ID multi-valued department does not follow with our rule. So the design has got a good BCNF and also complies with all the resultant following strategies for the 4NF, but it is not a good design to have this as in BCNF. So what we do, we just divide it with the ID department as well as the ID street and city. Now we can clearly say that the ID street and city multi-valued dependency lies within this 4NF. So we can say that a relational schema is in 4NF if and only if there is a multi-valued dependency alpha to beta Now the alpha, beta and all are the parts of R. Now we need to find the closure of the D plus, and in D plus we should find the 1, 2 and 3. So the first one is the alpha multi-valued beta. Then we can say that alpha belongs to R, beta belongs to R, and alpha beta combination gives us with this rule that alpha union beta will be equals to R. That means if I divide it in ID, street and city, so my alpha is ID, that is a part of the R, ID, street, city. Beta is the street and city, which is also a part. And alpha, beta, that means ID, street and city, is the relationship set attributes for the closure. So the first property holds for our 4NF. And now alpha is the super key of R. Here we can say that alpha, that is ID, is the super key of this relation ID, street and city, because ID is the minimal one which we can technically identify the street and city as a multi-valued dependency. So now if these two rules follows and are in 4NF and we have computed the closure of D, then we can say that this relation is in 4NF. Now, how to find a relation and then decompose it so that the resulting recomposed relation are in 4NF. Now, if there is an alpha defines beta, that is holds on R. Now, if one of the constraint violates, that means alpha is not a super key of R. So, if alpha is not the super key of R, then alpha defines beta doesn't imply that alpha multi-valued depends beta. So now we can say that this one is not also holding for our multivalued dependency, but it is not in 4NF because it is not the super key of R, as well as if it is not the super key of R, it cannot imply that from the functional dependency a multivalued dependency. So to be in this 4NF, we first define the closure of D plus. That means the closure of the attributes that present in the relation Ri. Now that the set D consists of this R1, R2 and Rn. So we can compute the D plus and then make a restriction to the D plus. What is the restriction? That some constraint need to be maintained while be in this D plus of 4NF. So if there are functional dependencies in D plus, that will be consisted of the attributes that is present in the relation Ri. So for R1, the functional dependencies is a part of the attributes. Say for this address city or the ID street city. So the ID multivalued street comma city is being a part of this first relation because the FD in D plus is consisting of the attributes ID, S and C. That is the relational schema of that Ri. Now the second one is there is any multivalued dependency, that is the beta intersection Ri. So if there is any other value other than the beta in Ri that is dependent on the multivalued dependency for R, that is alpha, so we can say that alpha defines the Ri, alpha is a part of the Ri, and also alpha defines beta is in closure of this attribute set. So let us discuss this carefully, that alpha is multivalued attributing, that is ID, S and C, which is the set of relation. Now if there is any other street and city that belongs to intersecting Ri, that means alpha defines alpha. So my alpha here is the ID and beta is the S and C, and my Ri consists of ID, S, street and city. Now if I intersect ID, S and C with this S and C, we will have S and C. So ID defines S and C. This is the first one. Now if and only if alpha defines Ri, obviously ID will uniquely identify the Ri, and also alpha is a part of the Ri, and then alpha defines beta is in the D plus. That means the first one is in the closure of this attribute set. Then the restrictions we should meet that of the 4NF decomposition, done be carefully. Now we will see an algorithm that how to decompose to an 4NF normalized form. So first I am starting with an initial schema R. I am taking a variable done as false. Now we need to compute the closure of D, and if the schema is Ri, then Di is a restriction of the D closure to the Ri. That means we cannot perform this restriction to the table or the decomposed table Ri. Now until and unless done become false, that means if done is true, we will perform the following task. Now we need to check for every Ri that is present in result but not in 4NF with respect to the description Di. So if there exists any relation, then we should begin it now. Now, if there is any Ri that is in result but not in RNF with respect to Di, then we should perform that we are taking this as a non-trivial multivalued dependency that holds on Ri. Then we need to prove that there exists no such non-trivial dependency. First, we are assuming that there is existing a non-trivial multivalued dependency. Now, this will happen in such a way that alpha will define Ri that we have just proved, not in Di. So, we cannot make the restriction that alpha is defining Ri into the Di in such a way that there is nothing intersected between alpha. Now, alpha and beta has got nothing in common. If it is the defining key, then it should be represented by alpha, and if it is the dependent keys, it should be represented by beta. No part that can be a defining keys part as well as a dependent keys part. So this restriction along with not a restriction, that is alpha defining Ri. Now we can say that the Ri is subtracted from result, that we will get the ACD. Now Ri minus beta, that means CD is subtracted from it, that means A will be added up and as a combination of alpha beta. So all will be the part of the result again taken for consideration. So now we should continue this until and unless we are finding some results that is not consisting of the result on the done becomes false. That is, there is no Ri that is present in result but not in RNF with the restrictions. Now that we have made our result to the new result that we have formed, subtracting the Ri, beta and alpha beta, then we should end our loop, because we should continue it until and unless we find some results that is all the Ri's consisting in 4NF with the restriction Di. Now finally, if there is no such thing, then we made done equals to false and we need not to continue the loop furthermore. Now if we perform this decomposition algorithm into our relationship set, that the ID, department, street and city, we will get two of the relations. Now see that how to perform this one. First, I am starting with the result set, that is ID, department, street, city. Now I am finding such Ri that no restriction belongs to this Ri. So there is no Ri for now that belongs to the 4NF. So we are finding a non-trivial multivalued dependency. That means the ID belongs to street and city. So it is holding on this Ri, but the alpha is not defining Ri. That means ID alone cannot define the department, street and city and the rest of it. So we cannot say that is not in Di. So it is not in Di. Already the ID multivalued SC cannot define this restriction. And alpha and beta is not also null, because if we intersect the alpha and beta, we will get department as a result. Now we need to decompose it. So we decompose it in such a way that ID, street and city become a part of it. So now as the result we have these two relations. In the ID department, there is no such non-trivial multivalue. Then the first one is just eliminated. And the second one, that is ID, street and city, we have this non-trivial multivalue dependency holds on Ri. Also the restriction, that is ID dependent on S and C, is also holding on the restriction field, and alpha and beta has got nothing in common. So now we can say that we have achieved the result set that cannot change more further, and we should stop our loop. So as a result of this algorithm, we can have the ID department and ID street city as a decomposed relation, which is in 4NF. Now if we talk about the multi-value dependency only that is present in D+. Now say if R is decomposed into two parts, that is R1 and R2. Now, any non-trivial multivalued dependency that lies within R, we can say that it will lie within the closure of D+. That means the domain set or the range of the D+. So now we can have two of the condition, and each of this or at least one of this should follow to satisfy in D+, so that we can say that the multivalued dependency is preserving on D+. So to hold that a multivalued dependency present and holds on Di, if and only if we have this two one or at least one of them. Now let us get back to our ID department and ID street city. If we intersect the relations and if there is any common thing, then that will depend or define multivalue on the first relation as well as the second relation. So for our case, ID is the intersection, and that multivalue defines the street city as well as it defines the department. So now it is proven that for our 4NF and in the decomposition algorithm holds on for these two cases. Now, if this exists, then we can say that the decomposition algorithm for 4NF only give the lossless decomposition. How to prove that? Let us take this example. We know that a functional dependency implies the multivalued dependency on it, so that the R1 intersecting R2 defines R1 is implying the R1 intersection R2 multivalue implies R1, and also it defines that this one implies R1 intersection R2 multivalue defines R2. So now we know that even if there is a form that defines R1 of intersection R2 in R1 and R1 of intersection R2 in R2, so it forms a lossless decomposition. Now that as it implies on a multivalued dependency 2 on two relations, that is a part of R which decomposed into R1 with the R1 set and the R2 with the capital R2 set is a lossless decomposition on 4NF, because this functional dependency implies the multivalued dependency in 4NF. So the 4NF provides a lossless decomposition as well as it preserves the multivalued dependency. So we can say that 4NF is the practical higher form or the highest form that we can achieve within a database management system, and we often this as the highest one because beyond this we have two or more forms, but that has not been taken in the real situations. So that is all for the BCNF to the 4NF and the multivalued dependency and the preservation of it in the 4NF. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.